Hi there, and welcome to our video on subtracting real numbers, subtitled, There's No Such Thing as Subtraction. And I've often kind of teased my own classes about this, saying, oh, your first grade teacher lied to you. There was no such thing as subtraction, this thing that you've been doing for years. But I think you'll see what I mean when we get into the lesson there. If you haven't watched my video on adding real numbers, be sure to watch that first. I'll put the link in the description box because what we're about to do in terms of subtracting the real numbers does require that you have a pretty good handle on adding real numbers first. And please don't forget to like and subscribe if this video is helpful, and post any questions that you have in the comments. So if you have questions about something that I cover in the video, or if there's something you'd like to see me make a video or short about, please let me know that, and I'd be happy to answer any questions that you have. So first off, what is subtraction? Well, in first grade, subtraction is introduced as takeaways. And so you get this idea of like you have, I don't know, we have like little red dots up here. So maybe we have 6 red dots and we're going to take away 2 of them. And maybe you even played with that on your desk at school. I know I had my school I went to, we had like little manipulators we could have on the desks. And so you count out 1, 2, 3, 4, 5, 6, and then you take away 2, and then you count however many are left, and you count them to be 4. And with that, you begin to develop this sense of decreasing the amount of something that you have or you're taking away. Now, this is actually a really useful way to continue thinking about subtraction in some instances. And there are times in my own classes when I'm teaching where I'll say, okay, we're going to flash back to takeaways because there's something about the way that we process that is very useful, even in higher level math. Now, what we're going to do is use our knowledge of negative numbers to generate a broader definition that's going to be more flexible and allow us to do more things. So we're going to define subtraction as simply addition of the opposite. And so we're taking subtraction and we're redefining it as addition, but we're going to add the opposite. Now, in order for that definition to make sense, you do need to know the vocabulary word opposite, because that's not going to help you if you don't know what that word means. And that's why vocabulary is so important, because our vocabulary keeps building and we use certain words. And if you're picturing one thing in your head and I mean something else, then that's where a lot of confusion can arise. So opposites are numbers that are the same distance away from 0, but on opposite sides. So the opposite of -3 is +3. The opposite of 4 is -4. And if you were to measure how far away they are from 0, you would see that they are the same distance, but they are on opposite sides. And that's why they're called opposites. So we're defining subtraction as adding the opposite of whatever number it was that we were taking away. So let's take a look at this, that this is an okay definition. So if you're back in first grade, okay, and the teacher gives you 8 little dots and says, okay, 8 take away 5, and so you, little first grade you're like, take away 5. 1, 2, 3, 4, 5. And then you realize that you are left with 3, and you come up with, okay, so 8 take away, or 8 minus, or 8 subtract 5 is 3. Now, on the number line, what we're saying is that subtraction could be redefined as adding, but instead of adding 5, we're going to add the opposite of 5, and the opposite of 5 is -5. And so looking at our number line, here's our 8. And that negative means we're going to be moving to the left. So we're going to go to the left. Let me change my color up here. 1, 2, 3, 4, 5. And you're wondering, well, where am I on the number line? So 7, 6, 5, 4, 3. And we realize, yes, we are indeed in the same spot. So 8 take away 5, or 8 minus 5, is the same as 8 plus -5. And I'm not going to drag you through more examples of that. You can maybe take my word for it that we could do a whole bunch of those and they would all come out the same way. Okay, so a couple of other examples of what this might look like. So this is pretty much an exercise in rewriting and changing the form of something. So 10 minus 7, as we look at that, we have the 10, and that's what we're going to be subtracting from. And then we're going to change the minus to a plus, so it's addition of, and then we're going to look at the opposite. So what is the opposite of 7? And so this can be rewritten as 10 plus -7. You'll also see it written that way with the -7 in parentheses. That often has to do with whatever program somebody is typing in, because it can look confusing if you can't make the negative look a little bit different than the minus sign. Okay, so you try to write it a little bit higher. It is the same symbol, but not everything has that flexibility. So sometimes people will set it apart using just the parentheses. Next one, 15, and then we're changing that minus to adding. So we're going to add the opposite, and the opposite of 4 is -4. And this will also work with variable expressions. So 2x minus 3 would be 2x, and then we'll change the subtraction to adding because we're defining it as adding the opposite, and the opposite of 3 is -3. So what you might notice in there is that essentially we're taking every subtraction symbol and we're writing it as a plus negative. Now, you may or may not find that really helpful. Now, when I took Algebra 1, the teacher that I had, he made us write all of our subtractions for the entire year as plus negative, plus negative, plus negative, plus negative. That's how we wrote all of them. So we never had a subtraction symbol. I have not shared at this point in the video series much about like my own math experience, but my mom is a math teacher, and she thought that was silly that we were writing that her daughter was doing plus negative, plus negative. But it really, really worked to solidify for me in my head what subtraction was. And so I actually think it's a pretty good idea for a lot of students to practice writing plus negative, plus negative, plus negative. And then when you really get the idea, then you can kind of go back to that minus sign. I don't still write plus negative on everything. I absolutely write subtraction symbols, but it took a while to get that level of comfort. And there's a couple of really common errors that you can avoid. Now, I want to bring it back to good old PEMDAS. This is our order of operations, and there's a video on my channel for that if you'd like to check that out. But a common misconception with order of operations, because of the way that we write it out, is people will say that, well, adding comes before subtracting because in the acronym, the A comes before the S. And I always try to write it with that little slash there to indicate like, no, they actually have the same level in order of operations, and we go from left to right when we see adding and subtracting. Well, once we understand subtraction as addition of the opposite, this should make more sense. So this is why the A and the S always go from left to right. We can rewrite any subtraction as an addition, which would give them all the same rank in the order of operations. So you'll see some stuff like this online sometimes. People will try to trick you, and they'll say, oh, you got to do adding before you do subtracting. And so they'll do 5 plus 1. Do not copy this down. They'll do 5 plus 1 and they'll get 6. And then they'll do 7 minus 6 is 1. And they'll be very, very confident that they got it right. Yes, I absolutely got that right because adding comes before subtracting, but it doesn't. It's left to right, and here's the why behind it. Once you understand subtraction as adding the opposite, that subtraction right there can be rewritten as adding a -5. And what that does is it turns the entire problem into addition. So it's really 7 plus -5 plus 1. And then looking at our adding of real numbers, we've got 7 plus -5. So we'll go 1, 2, 3, 4, 5 down here, and then plus 1 will bring us back 1, which will land us right there. So that'll be 6, 5, 4, 3. So the answer to that is actually a 3. 7 plus -5 is 2, and 2 plus 1 is 3. So hopefully that makes a little bit more sense to you as to why adding and subtracting do go from left to right, okay? And we don't want to get fooled by the mean internet, okay, with what the order is that we do things in. Okay. Now, commutativity. So commutativity is this property here that allows us to switch the order of things. So in other words, 4 plus 5 is the same as 5 plus 4. So adding is commutative. Subtraction is actually not commutative. So if I were to look at the problem 1 minus 3, that is not the same thing as 3 minus 1. Subtraction, you cannot just switch the order of things. And that becomes more apparent when we do our adding of the opposite. So 1 plus negative 3 is not the same thing as 3 plus negative 1. 1 plus negative 3, okay, if I sit there, now I'm going to add negative 3. So 1, 2, 3. So 1, 2, 3. That'll put me at 0, negative 1, negative 2. But 3 plus negative 1, so 3 plus negative 1, I would start here and I would only go 1 to the right, and that will put me at 2. Now you'll notice that we did get the opposites there. That is also not a fluke that we end up with negative 2 and a positive 2. But the point here is that they're actually not the same. But addition is, so rewriting subtraction as addition allows us to employ this property by reminding us to move the negative with the number. So if you had, say, 1 minus 3, and you actually did need to switch the order, you could rewrite that as 1 plus negative 3, and then you realize, oh, when I go to switch the order, I actually can switch the order. I just need to remember to move the negative with the 3. So this is a common mistake that students make, and one that you can avoid if you really understand subtraction as adding the opposite and are comfortable with that rewriting step. Now, what about subtracting a negative? The great thing about a good definition is that a good definition is still going to hold. So we have defined it as adding the opposite. So we have the 2. Here's our subtraction symbol. That's going to become adding. So we'll have 2 plus, and then we'll look at whatever number it is we're subtracting. So we are subtracting a negative 4. So you would ask yourself, what is the opposite of negative 4? The opposite of negative 4 is positive 4. So when you're subtracting a negative, you pretty much just have a really awful looking version of an addition problem. And this is where in some middle schools, this is taught as, or what is this, like keep, change, or something. I absolutely hate that because it's a little acronym and most students don't know why it works. So it's much, much better for you to know that subtracting is adding the opposite and then just work each problem that way rather than relying on a little acronym. Now, there is a neat connection here. There's an English language connection. A double negative actually reverses the meaning. So if you think of this right here as being a double negative, so you have your subtraction and then you have your negative, so you're doubling the negative, and it turns out that that's the same as a positive you're adding. I do not have no money in the English language. Like say, I don't have no money. It means that you must have some money because you do not have nothing. And so in terms of the strict meaning of the words that you string together, when you have those double negatives, so do not and no, they reverse the meaning on each other. So that's maybe another way to connect that to things that you already know. Last a couple of examples here. If you have a string of numbers, again, it's like left to right. And so we'd have 3 plus, so we're going to add the opposite of 4, which is negative 4, plus 5, and then we'll add the opposite of negative 7, which is 7. And what that does is it takes that string of adding and subtracting and turns it all into adding, which would allow you to then employ your commutative property and so forth. Okay, and you can do this on a number line by just kind of figuring where you are. So we're going to start at 3, then we're going to add negative 4. So 1, 2, 3, 4. So that puts us here. Then we're going to add 5. So 1, 2, 3, 4, 5, which is going to put us right here. And then add 7 beyond that. So 1, 2, 3, 4, 5, 6, 7. I think I counted that right. Hope I counted it right. So where were we? 4, and then this would be 5, 6, 7, 8, 9, 10. Did I count that right? 11? Yes. Okay. So we land at the 11. And you can always model anything on the number line like that. And if you watch my video on adding the real numbers, I really emphasize that number line. Not because it's something you're going to do forever or because it's like magic, but it really locks in your mental model of what we're doing with the numbers. And once you have that mental model, it will serve you well for years to come. Now, for this next one, we haven't covered a math concept yet that is necessary to carry this problem out all the way. But this is another huge spot where students do make mistakes and where rewriting as adding the opposite could really help. So we have that subtraction there. So we have 3x minus 4. And then we have in parentheses, so that's multiplication, x plus 5. This is what my Algebra 1 teacher made us do. So we had to write that as plus -4. And what that does is it reminds the person looking at it what you're actually multiplying by. So a lot of my students in this form up here would tell me that we're multiplying by a 4. Okay. But if you write it in this way, most of my students would say you're multiplying by a -4. And then the better you get at math, you would also answer that for up here. But when you're first starting to do it, that little notational rewrite can make it much clearer that what you're multiplying by there is a -4. So I hope that this video was helpful with subtracting real numbers. Again, if it was helpful or if you have questions, please like, subscribe to the channel, and communicate with me. Let me know what you'd like to see. I'll see you next time.